Now, homogeneous and heterogeneous. So homogeneous you were discussing. What is the basic difference between homogeneous and heterogeneous mixtures? Sorry. What is the basic difference between that? Yes.
In homogeneous, it's like the solute dissolves in solvent.
Yeah. Basically, the components of one, the particles of one component will dissolve, actually dissolve in the particles of other components. Fine. So that is why it is homogeneous. It is uniform. It is evenly distributed.
Hello, ma'am.
Therefore, hello. Therefore, it is called as homogeneous. Okay. The heterogeneous is different. Dissolving does not take place. The particles are suspended in the particles of other components. That is the basic difference. Now, in case of homogeneous, we started discussing the homogeneous mixtures. And what do we call them as? The homogeneous mixtures are called as solutions, right? And at times we can also refer to them as true solutions. So whenever I am referring to a solution, I am simply saying it is a homogeneous mixture and that the particles have actually dissolved. But it is a form of impure matter. Solutions are a form of impure matter. They are mixtures, not pure substances. Clear till here, fine. The next important point that we would have discussed is that in case of solution, now let's discuss what is a solution. Solution, first point, homogeneous mixture. Second point, it consists of a solute and a solvent. Solute, solute generally is the one which is in lesser quantity. Solvent generally is the one which is in a bit like more quantity, greater quantity. Okay. And basics example that we took in our day-to-day life, salt and water solution. Yes. Therefore, salt becomes the solute, water becomes the solvent. Similarly, we have sugar and water. Okay, so that is also a solution. Lemonade is a solution. Okay, we will have equal, like uniform taste all throughout if it has been mixed properly. I'm continuously saying that point. Okay, so that we discussed. Now coming to the next important point is that when we say that solution necessarily do not have to be just liquid. Since they are all matter, what we are discussing is matter, there has to be some physical state to them. So therefore solutions can also be solid, liquid or gaseous. Solutions can be either solid, liquid, or gaseous. It is not necessary that the solutions will be liquids only. Fine. The only characteristic of a solution is that two or more than two pure substances, components have been mixed uniformly, homogeneously. That is the only defining factor of a homogeneous mixture. Otherwise, nothing else. Now, we discussed the basic example of this salt and water as a liquid solution. We discussed the the gaseous solution. Yes. What is the example of a gaseous solution? Sorry. Yes. What is the example of a gaseous solution?
Air.
Air. Wonderful. So air is an example of a gaseous solution. Now, what is the solute in air and what is the solvent in air?
Ma'am, a solvent is nitrogen.
Good. Amar, why do you think beta solvent is nitrogen here in the case of air?
Yes, ma'am.
Why do you think beta that nitrogen is the solvent in case of air? Why not oxygen?
Ma'am, because nitrogen is present in less amount and oxygen is present. No,
Mm-hmm.
no, 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 no. Like nitrogen is present 70 percentage and oxygen 25 percentage. So nitrogen is a solvent. Solvent means the more.
Nitrogen beta is 78%. Good. Therefore, it is the component of the air which is the most in quantity. Therefore, it acts as the solvent to the mixture which is air. Fine. Good. I think, Macho, please remind me of this. We also discussed that why air, although appears to be a pure substance, but is actually an impure matter, right? Because it has a
Yes.
variable composition. We have discussed this, Bacho, that air has a
It's true solution,
air has
right?
a yes, we did fine. Okay. Now coming on to the next point. We said that what is the state of the solution determined by state of the solution will be determined by what? Lokia will answer this, बच्चे. State, just मतलब sorry beta. Lokia, the state of the solution will be determined by what? It was the state of the solvent generally that decides the state of the solution, the physical state of the solution. Fine. Coming on to the third, bachcho. Did we discuss the solid solution? Solid solution? Yes, bachcho? No. So that is the third part of solutions here. Please pay attention. I will not want to repeat it again. So give me one example of a solid solution. What will be a solid solution? We are saying that either the solute or the solvent, generally the solvent, okay, will be in a solid state. Yes, this would be a pure substance. Okay, this would be a pure substance and they would be mixed. But in what manner they would be mixed? What will be the nature of bonding here? Mithun, what
Yes,
will be
ma'am.
the nature of bonding here? Between a solute, which is pure substance, between a solvent, which is pure substance,
Physical.
physical bonding. Good. Therefore, they would be mixed physically. This Amar, what will be the composition here? Will that be fixed or will that be variable?
Fixed.
Lokia, will
Variable.
that be
Variable.
fixed? Either of the answers has to be correct, huh?
Variable.
This will be variable because it's a mixture. Always remember,
Yeah,
solution
ma'am.
is a mixture. It will be variable. Okay, fine.
That's why I
Thirdly,
told variable
the
after.
so thirdly, the properties of this solution will be totally different from this solute and the solvent, or will they be a combination of both the properties? Lokya,
Yes, ma'am.
answer me, beta. Will the properties of the solution be totally different from the properties of the solute and the solvent, or will they be a result of the mixture of the properties of the solute and the solvent here?
Um,
Bethel,
the
It will show the property of the mixture.
it will show.
It will show the property of the mixture.
It will show the property of the.
Now, ma'am, if we solvent, if we add solvent and solute, when we mix together, so it will show the property of that.
Of both of them, are you saying the properties of the solution will be a mixture of the properties of the solute and the solvent? Yes.
Yes, ma'am.
Fine. Exactly. Lokhe, you were saying something.
the properties of the solution like are not like totally different from the solute and solvent, but they're like combined.
Good. They are a result of the mixture. Good. Fine. So therefore, solid solution is this. Now, what will be the example of a solid solution? Quickly. Alloys. Alloys
Yes, ma'am.
are
Alloys.
examples. Yes. Alloys are examples of solid solutions. We will learn. See, alloys are this topic.
Ma'am,
Alloy.
can
This
I say
particular.
how are alloys made?
Just a second. Alloys is very important. It's a bit different. It has got some exceptions. I would request all of you to pay some good attention here. Ammar, go ahead with what is alloy.
Ma'am, alloys are made up of 70% copper and 30
Mm-hmm.
percentage zinc.
That is right, but that is one alloy that we are talking about. That is brass. Okay, we will discuss. Good. See, alloys basically are when metals mixtures. See, what are alloys? They are solutions, right? What are solutions? They are mixtures. The mixtures of metals and non-metals. Now, I hope all of you will know that what are metals and non-metals. I will not repeat it here. Okay. Metals and non-metals, better, they are pure substances, yes. And that is what we are doing here. We are just mixing two or more than two pure substances that will give us a mixture. And if the mixture has been mixed properly, dissolved properly, it will be a homogeneous mixture. And that is what we are studying here in case of solutions. Please try to relate everything and then understand. Fine. So alloys are nothing but mixtures of metals and non-metals. Good. First of all, example, let's take the example of brass. Brass is an alloy, okay, with zinc and copper. So zinc is a metal, copper is a metal, both of them being pure substances, and they are added in a particular ratio. So copper around 70%, zinc around 30%, that will give you brass. But the point here, sorry, but the point here is that important point is, see, if they are mixtures, what kind of bonding should be between these two metals, bacho? If they are mixtures, Mithun, could you respond?
Uh, they will. I think they will be like chemical.
But I am saying they are mixtures,
Not sorry, not chemical.
physical, right?
Physical. Sorry.
Physical, fine. So there should be physical bonding.
They have
What kind
variable
of,
component.
yeah, variable composition. And the properties should be
Uh,
result of both the components, right? Properties of both the components.
yes, ma'am.
That is what it should be. Components properties. Okay. See, there's just one different point here. In case of alloys, be mindful of what I'm saying. In case of alloys, the bonding between two or more than two elements. But so these are elements, right? Metals and non-metals are categorized under elements. Okay. So is not physical, but rather is chemical. Chemical bonding will take place. Now this point will can actually let us to say that alloys are pure substances because the nature of bonding is chemical. But what is actually aligning alloys towards mixtures is this property of variable composition. If had this been a pure substance, we cannot have a variable composition. Yes. Secondly, the properties are still a result of the properties of the components. These two properties make alloys what? Mixtures. I hope this point is because the nature of bonding is not physical, rather it is chemical, which is more similar to that of pure substances. Are you able to recall? I have been continuously saying that if the bonding is chemical, it is pure substance, right? There's just one exception here. Although the bonding is chemical here, but it is still mixture, which is impure matter because of these two properties, that is variable composition and properties being a result of the components, the properties of the components. I hope this point has been understood. Any problem here?
Yes, ma'am.
Yes, Mithun, any problem?
No.
Okay. Amar, has that been understood? Bethel and Lokya, bachcho, quickly write it.
Yes, ma'am.
Write it.
Yes, I'm
Write,
understood.
write it. So that is one point. But this becomes really important. Okay. See, zinc can also be present in 35%. Okay. Copper might be 65. So what are we seeing? We are seeing a variable composition. Yes. And basically, what is the purpose of alloys? The purpose of alloys is to mix the properties of two or more than two useful elements to get them in one element. In one alloy, okay, in one substance, and that becomes alloy. Is that okay?
Yes, ma'am.
So, have you written this down? Should I move ahead?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Quickly give me some other example of an alloy. Mm. What is the steel? Steel is an alloy, carbon plus iron, okay? So carbon is a non-metal, iron is a metal, both of them being elements, two pure substances mixed together chemically in a variable composition with the properties being a result of both carbon and iron to give you steel. Therefore, it's a mixture which is a solid solution. Understood, bachcho? Yes or no?
Yes, ma'am.
Any other example of alloy? Hmm. Yes, bachcho.
Brown.
Good, good. What is bronze? The composition of bronze? Around
Copper.
12%. Yeah, 12% tin, that is Sn, okay? Plus rest of it is mostly copper, okay? Done. Good. So this is also an alloy. Amar, in case of bronze, can there be solute and solvent? Yes or no? I'm asking. Can there be solute and solvent?
Yes, ma'am.
What will be the solvent?
Ma'am, bronze consists of like how many? There are two, right? You wrote.
Two
Can you say
elements.
the percentage?
12%. I've written it here, beta. 12% of percentage of tin. 12% of tin, that is Sn, and rest other is copper, like majorly. Hmm.
So, ma'am, solvent is copper.
Hmm. And solute is?
Solute is zinc.
Beta is tin, tin,
Yeah,
Tin,
tin.
tin.
Yeah, yeah, ma'am. Tin. Sorry, sorry.
And the
Tin.
symbol is Sn, okay? Symbol is
Yes,
Sn. This
ma'am.
is clear?
Yes, ma'am.
Fine. So that is a number. There are many other examples of alloys, solar alloy, alnico alloy. Okay, I'm just writing it here for your just
Ma'am, can
informational
I give an
purpose.
example?
Yes, please do.
Ma'am, steel is alloy, right?
Yes, beta, I've written it here.
Oh, yeah.
Steel is an stainless steel is also an alloy, nothing else. Okay, alnico.
Iron plus
Oh,
carbon.
yes, that's it. Can we move on to the next topic, but any problem till here?
No, ma'am.
Fine. Now, generally, what do we do is that generally
No
at your level,
concentration, right?
solute, solvent. So we said that the solute could be solid, liquid, gaseous. The solvent could also be solid, liquid, gaseous. And we have seen the different examples here. But generally at your level, what we are saying is that we are generally considering the solvent as liquid. We are generally considering the solvent as liquid, and we are just varying or changing the state of the solute. So we can have solid liquid, we can have liquid liquid, okay? We can have gaseous liquid, okay? Is it clear? So quickly open up your NCRTs.
Yes, I opened.
Sorry.
Ma'am,
See,
school says me the portion. School sent me the portion for half yearly exam.
okay, okay.
Uh,
Is it till the
up to
second chapter?
no, up to third chapter of what is third chapter?
Okay, Amar, we'll discuss that. Just,
Atoms
just
and
a minute.
molecules. Okay.
Amar, yes, just a
Okay.
minute. We'll discuss that in the last. So examples, a solution of sugar. This we have already done. In this solution, sugar is the solute and water is the solvent. Okay. Can you tell me what is the state here? Solid liquid, liquid liquid, or gaseous liquid?
Ma'am, a
What is the
solvent is
Liquid, liquid.
liquid
liquid, liquid.
liquid, huh? Because sugar is solute. Therefore, sugar is not liquid, bachcho.
And I
No,
thought join sugar
no.
water.
Okay. See, I did not ask the state of the solution. Okay. The state of the solution is definitely liquid because the solvent is liquid. Okay. Fine. No, it's good. A solution of iodine in alcohol known. This is important. Listen to this. Tincture of iodine. See, tincture means alcohol. Mithun, I hope you are attentive in the class and not doing anything else because I cannot see you. First of all, fix the camera correctly. Right on your face properly. Hmm. Now, so tincture of iodine refers to alcohol. Okay. So whenever iodine is mixed in alcohol, that acts as a very good disinfectant. Therefore, that is a mixture, but a homogeneous mixture, therefore a solution. Therefore, we are studying the example in this case. So a solution of iodine in alcohol is the tincture of iodine. Iodine is iodine is here in the solid state. Okay. Alcohol is in the liquid state. Therefore, we get the solution as liquid solution. Okay. So this is important. This is asked many times. What do we mean by tincture of iodine? Okay. Third, now please write it here. This is a disinfectant. Okay, just like spirits, we have seen the spirits. Okay, this is a disinfectant. Third, aerated drinks like soda, water, etc. Basically, what do we do when we have soft drinks? What do we do when we have cold drinks? We have some liquid. Okay, in that basically some gaseous component has been added. And what is that? That is nothing but a mixture between a gaseous state and a liquid state. Yes. A homogeneous mixture consisting of a gaseous component and a liquid component. Yes. Therefore, the carbon dioxide that gives those bubble and the taste of the soft drinks basically is a gaseous solute, whereas the liquid as solvent. Is it clear? Amar, I need you to respond because you have a very questioning face right now.
Yes, I'm
Air is a
clear.
mixture of gas and gas. Air is a homogeneous mixture of a number of gases, two main constituents. We have already done that. Any confusion till here?
No, ma'am.
Quickly come to this point. Solution is a
No, ma'am.
homogeneous mixture, two or more than two. Okay, substances always will mean pure substances. We have discussed this as the first point in pure substances. Okay. Laminate is the same. That's it. Now, alloys, what are alloys? Mixtures of two or more than two metals or non-metals and a non-metal and cannot be separated. Okay, that's a good point. We were discussing that pure substances, they are chemically bonded. Therefore, they cannot be separated by physical methods of separation, right? Whereas mixtures, that they are physically bonded because they have a variable composition and therefore they could be separated out by physical methods of separation, right? What about the alloys? They have chemical bonding, yet they have variable composition. What can be the case with them? How can they be separated?
ಇದರ
Yes,
face ಮಾಡ
hmm. How can they be separated? Can they be separated through physical or through chemical methods? What is the nature of bonding in alloys?
Ma'am, I think they can be separated through physical methods.
Okay, good. But what is the nature of bonding, bache? In alloy?
Physical. Physical.
Methuen, you were not attentive. I knew this. Bethel, did I not explain right now in detail what is the bonding, nature of bonding in alloy? What is the nature of bonding in alloy?
Chemical.
Chemical. And was this the exception? Was this the only exception discussed in alloy?
The variable composition and the property result of the compound.
Was this the only exception I asked? Yes, that was the only exception. And Mithun was not attentive. Ammar, beta, either you study or either you talk to him. Fine. Listen, all of you, pay attention. If alloys, if anything is chemically bonded, it will be need to like it is separated by a chemical method of separation. And that is the same case with alloys. Although they are mixtures, but since they are chemically bonded, they will be separated by chemical methods of separation. They cannot be separated by physical methods of separation. Okay. But still, it's considered as a mixture because it shows the properties of its constituents or components and can have variation. Bethel, Ammar, and Lokya, did we discuss all of this? Any confusion here? We have understood all of this, yes or no?
No, ma'am.
Right. For example, this. Just a second. Okay, fine. So coming on to the next topic. We have discussed. Yes. So now we discuss the properties of the mixtures, overall properties of mixtures. Okay, we discuss the properties of alloys specifically. Now quickly discuss the properties of solutions very quickly. So all the properties of solutions are because of these characteristics. First, is it a homogeneous or a heterogeneous mixture? Bachcho quickly.
Homogeneous.
Solu homogeneous. Okay. Second, see these points are really important now. Why is it a homogeneous mixture? That is the point here. Let's say beta, these were the particles, okay, which are mixed. This is the solute particles, okay, and these are the solvent particles. Clear? These are mixed here, dissolved here, only when the size would be small enough so that they are able to fit here. Yes or no? Yes. If I'm saying that actual dissolving is taking place in case of homogeneous mixtures, what is the reason behind that? Can I say it is because of the size of the particles? Do you agree with that? Yes or no? Bethel, respond. Amar, respond. Lokia, respond. Bethel, is it not understood? What did I just say?
Yes, ma'am, is
No,
understood.
ma'am.
Then respond.
No, ma'am.
All of this depends on the size of the particles. And very important, in case of solutions, we are discussing the properties of solutions, mind it. In case of solutions, the size of particles is less than 1 nanometer,
Yes, ma'am.
is less than 1 nanometer. Now, 1 nanometer is equal to 10 raised to the power minus 9 meter. Basically, it's very, very, very small. Because the size is so small, the dissolving takes place. And because of all of that, the properties, the characteristics are there. Is it clear? The third important point is that when the mixture
Ma'am,
is
one
left
question.
un yes,
Ma'am, in both heterogeneous and homogeneous, the particles are less than
no, no,
the
the
particles
particles,
are
no, the size of
the
the particles,
particles are less than 10 nanometer.
beta, beta I've written 1 nanometer first of
Yeah.
all. Second,
Yes, ma'am.
that in case of homo and heterogeneous mixture, the size of the particle plays a very important role. Therefore, the size of the particle is different in both the cases. Okay.
Okay, ma'am. Thank you.
The third point, when the mixture is left undisturbed for some time. This is important, but you try to understand. Undisturbed for some time. Okay. It will not happen that we mix sugar in water and the sugar will start settling down if it has been mixed properly. I'm continuously saying that. Okay. It will not settle down at the bottom, even if it has been left undisturbed. That is because the dissolving would have taken place. Why the dissolving would have taken place? Because of the size of the particles, the small size of the particles, okay? And if the mixture is left undisturbed for some time and nothing settles out at the bottom of the container, okay? Nothing settles out at the bottom of the container, it is referred to as a stable mixture. Why stable? Because it is there as it was made. It is there as it was made. Okay. Amar beta, sit properly. There are some etiquette as to how we need to sit in the class. Okay, please. You're a good student. Please learn these things. Very important. Okay. So left undisturbed for some time, therefore it will result in a stable mixture. Is that clear to all of you? And why is it happening? The
Ma'am.
solutions are stable because of the solutions are stable
Size
because
of
of
particles.
size of the particle. Okay. Bethel, you are saying something? Please say that.
No, ma'am.
Fine. The third point is that solutions which are mixtures, nothing but homogeneous mixtures, do not show Tyndall effect. What do we mean by Tyndall effect? Tyndall effect means, let's say these are the particles, okay, of the mixture or the solution. These rays of light are coming, okay. Since the particles here, in the case of solution, they are very, 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 very small, okay, the light can pass as it is. It will not get scattered like this because of the size of the particles. Are you getting it? In simple words, if you are moving on a road which is not crowded, you can move straight away, yes or no? But rather, if you are moving on a road which is very crowded, you will have to change your route like this. Are you getting this? That is nothing but the same concept here. Since the particles, since the particles are very, very, very small here, the path of the light does not get scattered. The rays of the light does not the rays of the light does not get scattered. If they are not getting scattered like this, the path of the light will not be visible. The path of the light will not be visible. Are you getting it? Therefore, that is Tyndall
Yes, ma'am.
effect. What is Tyndall effect? Please write this down. Scattering, scattering of light rays by particles to make the light path visible. Light path visible. Okay. What do we mean by light path? The path on which the light is traveling. Okay. Now, if the scattering is not taking place in case of solutions, do you think the path of the light will be visible? Scattering of light rays by particles to make the light path visible. That is what I've written here. To make the light path visible. Okay, done. Lokia, have you written this down, beta?
Yes, ma'am.
Now tell me one thing very important. If the scattering is not taking place here, okay, if the scattering is not taking place here, will the light path be visible? Yes or no?
Yes, ma'am.
Will the light path be visible? Yes. Mithun said yes. Okay. Bethel, your answer? If the scattering is not taking place, will the path light be visible? Yes or no? Will the path of the light be visible? Yes or no, bache?
Yes.
Yes. Ammar,
Yes, ma'am.
will that be visible if the scattering is
Yes,
not
ma'am.
taking place?
Yes, ma'am.
Lokia? Okay.
No.
No. I just now told you what is Tyndall effect. Tyndall effect is when light will get scattered, then it will be visible. When the light rays will get scattered, the path of the light will become visible. I'm repeating, pay attention. When the light rays will get scattered, the path of the light will become visible. When the light rays will get scattered, the path of the light will become visible. The point here is that the scattering is not taking place. Now will the path of the light become visible? Yes or no?
Yes, ma'am. If the,
Mithun
I mean,
beta,
if the scattering does not take place, it will not be visible.
yes, good. So basically, no scattering. Simple word, path light not path of the light not visible. Good, Lokya. Okay. And that is why we say that solutions do not show Tyndall effect. Okay, do not show Tyndall effect. Is it clear, bacho? I hope that is clear.
Yes, ma'am.
So we have discussed 4 properties of the
Ma'am, one
solution.
question.
Mm-hmm.
If we put if you take one glass of water and I put a sand, so the light will be not scattering towards that solution, right?
Sand, first of all, tell me, sand will not dissolve in water. Will sand be
Yes, ma'am.
dissolved in water?
No.
So that is not a homogeneous mixture. And if that is not a homogeneous mixture, that is not a solution. And if that is not a solution, definitely it will go against the properties of the solutions which we have discussed here. Are you getting it, Amar?
Oh yeah. Yes. Because it's written that copper sulfate does not show Tyndall effect. So
Yes.
like
So
copper.
now tell me, I will discuss this point at the last of the chapter when we have discussed the colloidal solutions, the copper sulfate point. Okay. Then you will show, like we will discuss this copper sulfate solution. Fine. Quickly to summarize the properties of the solutions. Homogeneous. The size of the particle is very small. What's the size of the particle here? Less than
1
less
nanometer.
than 1
Less
nanometer.
than 10, I like
Beta is not 10, 1
1 nanometer.
nanometer. Okay. Yes. Please go with 1 nanometer. Okay. The third point is good. The third point is that is it a stable or an unstable mixture? Is it a stable
Stable.
or an unstable mixture? Why is it a stable mixture, Amar? No one will answer.
Yes, ma'am.
Why is solution called as a stable mixture and not an unstable mixture? Hmm. Bethel, why is it called as a stable mixture?
Because the solid particle do not settle down.
Why they do not settle down?
When we left undisturbed. When we
Hmm.
left
Yeah.
undisturbed.
But why do they not settle down?
Because it makes
It
like uh because it makes
Mithun, why do the
properly.
particles not settle down in case of solution?
Ma'am, because of the size of the particle.
Hmm. Look here, what happens because of the size of the particles? What is actually happening here? Happening there because of the small size of particles in case of solution? Hmm.
Um, the particles are really small, so um, they will be left undisturbed.
Mm-hmm. Beta, we have been, I don't know what is wrong with you, Bacho. We have been continuously using these terms that what is the basic difference here? Dissolving takes
Ma'am,
place. And why is it that the dissolving, Mithun was somewhat right, but he did not use the right term here. The small size of the particles will lead to this. And if this is taking place, why will they like be like separated out? Yes?
ma'am, that's what I said, right?
Yeah, that's what I'm saying. You said that because of the size of the particles, that's right. I'm saying that. But what is happening because of the size of the particles? That is this dissolving. Yes? Because the
Yeah,
size of the particle is very small, dissolving actually takes. Are you getting it? What I'm trying to say here. All 4 of you, especially Ammar.
yes, ma'am.
Ammar, beta, if you're not getting it here, I don't know. Huh?
Yes,
Anyhow,
I'm
coming
getting.
on to you did not answer one question
Yes, ma'am.
rightly. Work hard. Coming on to the next topic, that is concentration of solutions. What do we mean by the concentration of solution? Okay, but since we have 10
Ma'am,
minutes
like,
left, yeah,
for
sorry, just
example,
a second.
mass
Yeah,
by
just a second,
mass,
sorry. Yeah,
that.
that's right. Today we'll discuss 2 other mixtures. The mixtures we discussed, heterogeneous and homogeneous, yes or no? Homogeneous we have already discussed. The other mixture we will discuss today, that is heterogeneous. Okay, I will not go in details here because you have already discussed the basics. So what is heterogeneous? No uniform mixing, yes. No even distribution. Basically, no dissolving, right? No dissolving.
They are
Okay.
not
And if
dissolved.
yeah, good. And if no dissolving is there, we will be
Can be
able to
separated as
see the
physical means.
beta mixtures can be separated out by physical means. Are you getting this? That is the point here. Do not confuse the things. Okay. Try to understand the basics. Wherever there is physical bonding, you can separate them out by physical methods of separation. That is the simple concept here. And what is it that is having physical bonding? Mixtures are having physical bonding. Are you getting this? All three of you. Method is also there. All four of you, yes? Thirdly, in case of heterogeneous mixture, no even distribution, no dissolving, suspension of particles is there. Okay. The third one, because of all of these properties, the boundaries, the distinct means different, distinct boundaries of particles visible. Particles visible. Example, let's see, take the example of sand and water. What will happen in there? When we mix sand and water, bacho, what will happen?
They will not dissolve.
They will not dissolve. Okay. Now, if they are not dissolving, therefore there is no even distribution. There will be some part of the mixture which will having a higher concentration of the sand, and there will be some part of the mixture which will be having somewhat lower concentration of sand, right? Therefore, there will be no even distribution. Why? Because there is no dissolving, right? The third, can you separately see sand and water? This is a sand, like these are the sand particles. This part is water. Yes or no? Therefore,
Yes, ma'am.
therefore there is no uniformity. Therefore, distinct boundaries of the particles can be seen or are visible. Tell me, are these points clear?
Yes. Yes, ma'am.
Now tell me, will they also have variable composition?
Yes.
Yes. If they will have variable composition, what will be the nature of bonding here in case of heterogeneous
Physical.
mixture? Physical. Look here. What will be the bonding here, bachcho?
Chemical.
Ammar, tell me, in case of heterogeneous mixture, the property of the mixture, will that be different, completely different from the constituent, or it will be a result of the constituting particles or the constituting substances?
It will be the result of constituting particles.
Okay, Bethel, yes.
Yes,
What do you think will be the bonding here, chemical or physical? In
physical,
case of heterogeneous mixtures, huh?
physical,
Physical. If it is physical bonding, what will be the method of separation used here? Chemical or physical?
Physical.
Physical. Bethel, will there be variable composition or a fixed composition?
variable composition.
Variable composition. Good. All of these are the properties of mixtures, and heterogeneous mixtures are again a part of the mixtures. Okay. So all the properties of the mixtures that we studied are applied to the properties of the heterogeneous mixtures. Is that clear? We are simply trying to understand the difference between homogeneous and heterogeneous mixture. And what is the basic difference between homogeneous and heterogeneous mixture? It is because
Yes, ma'am.
am I done? Should I continue? Or should we wait more? Tell me. We have some 80 minutes left here. Beta, please. So the basic difference is in case of homogeneous and heterogeneous mixtures, the basic dissolving will take place in homogeneous mixture and it will not take place in heterogeneous mixture. Because of that, the difference in the properties will follow. I hope that point is clear to all of you. Okay, fine. Now coming on to the heterogeneous mixtures, we have two different types of heterogeneous mixtures. One is the suspension Beta, we are just talking about the heterogeneous mixtures. Do not get confused. The other is the colloid or the colloidal solution. Okay, colloids or the colloidal solution. Now, one point that I left, I'm sorry for that. In case of the properties of the solutions, this point, if they are left undisturbed for some time, they are stable mixtures, right? We are referring to the solutions well. Okay. And if they are stable, basically they are not getting separated into the components. Can we filter them out? Can we filter them out? Yes or no? Can we separate them through filtration? Let's say we have mixed sugar and water very properly. Okay. Now, can I just separate them by filtering it? Yes or no?
No, ma'am.
Good. So basically, whenever the mixture is stable, filtration cannot be used. I'll give you one example here. Try to understand it. Okay. Let's say that seawater is a mixture. Okay. So seawater has got water and salt. All of you will agree to this? Yes or no? Okay.
Yes, ma'am.
Now it has got water and salt. So let's assume that is a solution, a homogeneous mixture that is a solution. Fine. Now what will happen? Since it's a mixture, some physical method of separation has to be used, right? Since it's a mixture, physical bonding is there, some physical method of separation has to be used, right? But since it's a mixture, it is a stable mixture, right? I mean, since it's a homogeneous mixture, it's a stable mixture, right? The components are not getting separated into like different components, right? Therefore, we cannot use filtration. What is the method of separating out salt from water, seawater? What is it? Do we use evaporation?
Heating.
Yeah, basically we evaporate, right? Mithun, that's right. We heat through evaporation. What happens? The water is evaporated. What is left there?
The water
Salt
is
is left there.
evaporated and salt
Yes.
settles down.
Yeah, exactly. Salt is left there. Like salt will not settle down. It is left there as it is. The water will get evaporated. Okay. But again, that's a method which is physical method of separation. Are you getting it? Although we are using a different physical method of separation, but filtration, which is also a method of separation, cannot be used. Are you getting this, like, to all four of you? Yes or no? Any mixture which is stable cannot have filtration as the method of separation. Any mixture which is stable cannot have filtration as a method of separation, and that is very simple. Let's say I have completely mixed. You just imagine it. You have mixed completely salt and water. You filter it. Will salt separate out? Will salt separate out? Yes or no?
No, ma'am. It will not separate.
No. Let's take any other example. Let's say we have mixed sand and water. Sand will obviously settle down at the bottom just in a minute,
It will,
and then you
it will
can filter it
separate
out.
it.
Yes, we can separate it. Right? Are you getting it? Whenever the mixture is stable, no filtration, but some other physical method will be used. But the method of separation will be physical or
Not
chemical.
filtration.
Yeah, but overall, will it be chemical or will it be physical?
Physical.
Physical. Any four of you, any problem in this concept?
No, ma'am.
Lokya, Bethel, Amar, respond.
No, ma'am.
Fine. So coming to the suspensions and the colloids and the colloidal solution. So since they are heterogeneous mixtures, what will be the properties here? I'm just quickly writing the properties. We'll be able to understand it here. Okay. First
It
property,
is
it's a heterogeneous mixture. It's a heterogeneous mixture. Okay. Beta, this is for the suspension. Clear? Second, very important. Since it's a homogeneous mixture, that means no dissolving will
happen.
happen. Good. The particles of one component will be suspended onto the particles of other component. Okay. Why is that happening? Size of the particle, please pay attention to this. Size of the particle is more than 1000 nanometer. There it was less than 1 nanometer. Yes. Here it is more than 1000 nanometer. You can clearly see the difference. Therefore, dissolving will not take place. And if dissolving will not take place, what will happen? Will it be a stable mixture or will it be an unstable mixture?
Unstable.
Bethel,
Unstable.
unstable or stable?
Stable. Unstable.
Unstable. Lokya,
Unstable.
Ammar,
Ma'am, unstable.
unstable. It's an unstable mixture. And if it's an unstable mixture, can we use filtration here? Can we use filtration here?
Yes, we can use filtration.
Yes, ma'am.
Good.
Yes, ma'am.
Filtration.
Filtration possible.
Good. Can. Clear? And now fourth point, Bacho. Since the particles are quite big, don't you think the rays of the light will be scattered by them? The particles are big in size, right? The particles are big in size. Let's say these are the particles, okay?
They will
The
be
light,
scattered.
yes. So therefore they will be scattered. And if the rays of the light are scattered, can we see the path of the light? Yes or no?
Yes, ma'am.
Therefore, suspensions show Tyndall effect. Are you getting it? All four of you. We can clearly see the difference here. Why is this a heterogeneous mixture and why was solution a homogeneous mixture? Clear, bacho? And what is the example
Yes,
here?
ma'am.
Very quickly, some examples of suspension.
Um, Salt and water.
Huh?
Salt and water.
Salt and water, beta.
Ma'am, water and oil.
Water and oil. Good.
Ma'am,
Sand and
like
water.
you are
Did
asking
you just say
for
sand?
suspension or solution.
I'm asking for the suspension, beta.
Suspension.
Sand plus water.
Sand and water.
Yes. Chalk powder.
What,
Okay.
ma'am?
Chalk powder plus water. Okay. You getting it?
Yes, ma'am.
Ammar, you must have seen the preparation of a dough, right? How do we prepare a dough for roti? You must have seen
Yes,
that.
ma'am. Yes, ma'am.
Can that be a suspension?
Sorry, ma'am.
Can that be a mixture, first of all?
Yes, ma'am.
And can that be a suspension? Homogeneous mixture or a heterogeneous mixture?
Homogeneous mixer.
Homogeneous mixture, huh? Look here. Homogeneous, heterogeneous.
Heterogeneous.
Heterogeneous. Bethel. In heterogeneous, suspension or colloid?
Suspension.
Suspension. See, we are able to clearly see the particles of the atta and pani, okay, separately. The flour and the water particles are clearly seen to us. Are you getting it? Therefore, it's a suspension. Mithun, any other point?
What, ma'am?
Any other question? Any other point? All four of you?
No.
I'm stopping it here today. Two important, three topics are left basically. Colloids we will discuss, the concentration of the solution, and the physical and the chemical changes. Okay. But you will have to revise it and respond in the class. And tell me what is the problem for not responding in the class? What is it? Mithun does respond at times. Bethel also at times can respond. Ammar, beta, what is the problem? Huh? You need Ammar, wait for all of you can leave, bache. Ammar, you will wait. Okay, all of you can leave. Thank you.
Thank you, ma'am. Bye.
Thank you, ma'am.
Revise, huh? All three of you.
Bye, bye, ma'am. Take care, ma'am.
Thank you. Bye. Ammar, yes. I'm stop sharing. Yes, Ammar. Tell me, beta, what is the problem? You can be very free with me. Please say that. At times, you're not focused in the class. I try to say that very leniently at times. I do not want to say it in front of everyone, but then you actually force me to say it like that. Still, huh? Mm-hmm. Ammar, are you listening to what I'm saying?